Next chapter, we are going to take TensorBoard visualization. TensorFlow includes a visualization tool which is called TensorFlow. Visualization tool TensorFlow. It is used for analyzing data flow graph and also used to understand machine learning models. The important feature of TensorFlow includes a view of different types of statistics about the parameters and details of any graph in vertical alignment. Deep neural network includes up to 36,000 nodes. TensorBoard helps in collapsing these nodes in high-level blocks and highlighting the identical structures. This allows better analysis of graph focusing on the primary sections of the computation graph. The TensorBoard visualization is said to be very interactive, where a user can pan, zoom, and expand the nodes to display the details. The following schematic diagram representation shows complete working of TensorBoard visualization. Cross entropy, train, connecting like this, predictions from accuracy also expected, train, interconnection, cross entropy, layer 2, layer 1, input, internally train connect. The algorithms collapse nodes into high-level blocks and highlight the specific groups with identical structures, which separate high-degree nodes. The TensorBoard thus created is useful and is treated equally important for tuning a machine learning model. This visualization tool is designed for configuration log file with summary information and details that need to be displayed. Let us focus on the demo example of TensorBoard visualization with the help of the following code. Import TensorFlow as TF. Constants creation for TensorBoard is visualization A equal to TF constant of 10, name equal to A, like this 90, name equal to B, in Y, here variable, here constant, here variable. This TF already knows variable TensorFlow. A plus B into 2, name equal to Y. Model TF initialize all variables, creation of model. With the TF session merged, all summaries here merged. Writer, if TF train summary writer, following session groups. Temp TensorFlow logs session group, graph, session and model. Print session dot run of Y. The following table shows the various symbols TensorBoard visualization used for node representation. Simple, like this symbol, high-level node representing a name scope. Double click to expand a high-level node is the meaning for this symbol. And the second one is sequence of numbered nodes that are not connected to each other. Sequence, not connecting each other. A sequence of numbered nodes that are connected to each other. Connected. Here connected. An individual operation mode only one. A constant summary node. Edge showing data flow between operations. Edge showing the control dependency between operations. Dot line here. Here, tick line. This color. A reference edge showing that the outgoing operation node can mutate to the incoming tensor. Next chapter, that is 10th chapter, tensor in TensorFlow. Word embedding. Word embedding is the concept of mapping from discrete objects such as words to vectors and real numbers. Discrete subset to vectors and real numbers such as words. Discrete objects with words. It is important for input for machine learning. The concept includes standard function which effectively transform discrete input objects to useful vectors. The same illustration of input word embedding is as shown below. Blue, blues, orange, oranges. The same illustration of input word embedding is as shown below. Word to VEC vector. Word to VEC is the most common approach used for unsupervised and word embedding technique. It trains the model in such a way that given input word predicts the word's context by using skip-grams. TensorFlow enables many ways to implement this kind of model with increasing level of sophistication and optimization and using multi-threading concepts and higher level abstractions. Import OS, import Max, import NPS, NP, import TensorFlow STF from TensorFlow contribute TensorBoard plugins, import projector, patch size 64, embedding dimension 5, negative 78, log directory, log word, vector introduction, digit to word map equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, digit word map, sentences, square bracket, open and close. Create two kinds of sentences. Sentence of odd and even digits for I in range 10,000. Random add ints np random choice range 110 2, 3. Sentence append join digit to word map of R for R in random odd ints rand even in ints np random choice range 210 to 3. Sentences append join digit to word map for R in random even ints map words in the indices. Word to index map index 0 for send in sentences for word in send lower speed. If word not word to index map word to index map word index then index 1. Index word map index word forward index in word to index map items vocabulary size length index to word map. Generate skip gram pairs. Skip gram pairs for send in sentences tokenized send lower and split for I in range 1 length tokenized send into -1 word context pair word to index map token size send I -1 here all are almost same So here only change I plus 1 only I. Keep gram pairs happen 4 context pair of 1 0 0 1 1 0. The def get underscore skip gram patch size instance indices list range length skip gram patch np random shuffle instance indices patch instance indices patch size x equal to skip gram patch I of 0 I into 0 I in one closed and open square bracket like this 0 also for in I in batch y skip gram batch save here I into 1 or I in batch 1 batch not 1 batch 1 return xy patch example patch x patch y patch equal to get skip gram patch 8 x patch y patch index to word word for word in x batch index word map word 0 for word in y batch input data labels train inputs tf dot placeholder tf integer 32 shape batch size train labels tf placeholder tf integer 32 shape batch size 1 embedding lookup table currently only implemented in CPU with tf.namescope embeddings tf variable tf random uniform vocabulary size embedding dimension -1 1 name embedding. This is essentially lookup table embedding tf dot embedding lookup embedding train inputs create variables for the NC loss. Nice. Sorry, NCE underscore weights equal to TF dot variable TF truncated normal into vocabulary size embedding dimensions standard deviation 1 math square root embedding dimension NCE biases equal to TF variable TF figures vocabulary into vocabulary size loss equal to TF reduce mean TF neural network NCE loss weights equal to NC weights biases NC biases inputs embedded labels sorry embedded labels train labels number sampled negative samples number of the class vocabulary size TF summary scalar NC loss learning rate decay global step if variable 0 trainable false learning rate TF train exponential decay learning rate 0.1 global step global underscore step decay step 1000 decay rate 0.095 staircase true train step equal to TF train gradient descent optimizer learning rate minimize loss merge TF summary merge all with the TF session as session train writer TF equal to say TF summary file writer log directory graph equal to TF get T graph saver equal to TF dot train dot saver with open as bar join log directory metadata dot tsv as metadata right name class n for kvn indexed to word map dot items metadata right like this configure projector config embedding configure embedding added embedding tensor name embedded names link this tensor to its metadata file example